Hey everybody, how's it going? Welcome back to the channel. A few hours ago, I bought a Diet Coke from a vending machine, and that really got me thinking as to how vending machines work, at least from a software perspective. And I came up with the conclusion that most vending machines follow a serverless architecture. And after research, I realized that that was true. And that kind of prompted me to create this course about serverless and explain to you what serverless is and how it differs from a prototypical client server model. So to explain what serverless is, let's just talk about exactly how typical applications work. So let's say that you have an application and it's running in the browser, and some user went on this application. So when they go on this application, they're going to be making a bunch of requests to your server. Now, in a typical client server model, you have a client and you have a server that is always running that is going to be listening to any HTTP requests. So let's say, for instance, that this is a to-do application and a user goes onto it and wants to add a to-do. They're going to make an HTTP request, probably some sort of post request to the server. The server is always going to be running. It's going to catch that, run some sort of code, and then it is going to send back a response. Now, if no request is being made, this server is still going to be up and running. Now, if another request was made, let's say a GET request to get all of the to-dos, well, it's going to make a GET request to that same exact server. That server is going to process it, and then it's going to go ahead and send back a response. But one thing to note is this server is always running. It's consistently running in the background. Whether it is being used or not, it is always going to be running. So now let's talk about serverless. So as you can imagine, with serverless, we don't have a consistent running server. It's actually what happens is, let's say we have the exact same to-do application, and instead now we're using a serverless architecture. Now, once the user goes onto our web, and let's say they make that same add to-do post request. Well, what happens at that point is you make the request, and whatever cloud provider you're using is going to create a function. And a function is just a block of functionality that contains a little bit of code. And that block of functionality, that code, is going to deal with adding a post. So whether that's, validating the post and then adding it to your database and then sending back a response. And that's pretty much it. But one thing that's great about this is that function wasn't existing before. So it was never running in the background. It was actually created when this HTTP request was made. So once this HTTP request was made, this function was created. It basically did all of the execution, saved it to our database, and sent back a response to our client. And then when it's not used, when no more HTTP requests are made, then it actually disappears. It gets destroyed. So there's no consistent running server in the background. You only create something, you only create this function, this code executable, if you are actually using it, if you need to use it. Now let's say you go ahead and you make maybe not a post request, maybe you do a GET request. Well, that is going to spin up a different function that has a different block of functionality, and that is going to deal with all of the code needed to get the to-dos into the browser. So whether that's going to the database, fetching them all, and then sending it back. But again, this function will never exist if you never trigger it with this HTTP request. And that right there, in a nutshell, is serverless. You only create what you are using. You never have this consistent running server. Now, what triggers the creation of a function? Well, what triggers the creation of a function in this case are HTTP requests. So if I were to make a post request, I create a function that deals with that logic. If I were to make a GET request, I create a function that deals with that logic. But there's many more triggers than simple HTTP requests. We can have, for instance, so over here we have HTTP requests, and that can trigger a function that saves it to the database. But we can have other things. For instance, we can have a trigger that when we save an image to S3, it spins up a function that has all of the code to resize and optimize that image and then resave that into S3. Similarly, we could have another trigger. Let's say we want to run a job every single day at 12 o'clock. Well, that could be a trigger. Once we hit 12 o'clock, we can have some sort of trigger that triggers the spin up of a function, and that is going to go ahead and run a certain job for us. Maybe it's going to clear the database, or it's going to do some sort of analytics. At the end of the day, it's some sort of cron job. But we can basically trigger a Lambda function or some sort of function to do that through a certain time of day. Another thing we can do is, hey, once the payment is complete, that could be a trigger for some sort of function to spin up and execute some sort of code involving sending an email to that particular user. So we can have multiple triggers out there. These are just 4 examples, but we can have a lot of different triggers. And they're going to trigger the spin up of a function, which again is a block of execution. This is going to execute some code that we want. Alright, so that right there in a nutshell is serverless. Now let's start talking about the pros and cons of serverless. So one big pro of serverless is that it's very cheap compared to having a server. And let's just talk about exactly why that is. So when having a server, you're always running that server. So no matter whether you're using it or not, you're incurring cost. So you could not be using it at all. Maybe you have no people using your application, but because it's always going to be running, you're always incurring cost. So that is a very big con. Now with serverless, you only pay for what you use. Because if nobody is using your application, there's nothing up and running. But if somebody is using your application, well, okay, that's fine. You go ahead and you spin up a function, and yes, you do end up paying for this function. But now if nobody is using your application and making that request, well, that function goes away and then you stop paying. So you only pay for what you use. And I know for AWS, you get your first 1 million functions for free or something like that. So it's very cheap. All right, cool. So let's talk about another con. It is fully, or another pro rather, it is fully managed. And this is really great. So whether your application is making 1 request or 1 million requests, it doesn't matter. The cloud provider is going to manage it for you. So you don't even have to worry about the DevOps. So with a typical server, you actually do have to worry about the DevOps. So if your application is making 1 request, okay, maybe it's fine the way that it is. But if all of a sudden it spikes up to 100,000 requests an hour, well, you really have to think about your architecture. You're gonna have to think about horizontal scaling. You're gonna have to kind of really do these things manually. Whereas with serverless, if your application is making 1 request per hour, okay, that's fine. It's just gonna go ahead and spin up 1 function. But if it's making 1 million requests per hour, okay, that's also fine. You don't even have to worry about it. All that it's going to do is just spin up more functions to handle those requests. And you really don't have to worry about the architecture, whether your application is making 1 request per hour or 1 million requests per hour, which is really insane. And I'll show you an example of a company that only has a team of 1 DevOps engineer, and they're making thousands of requests an hour. And that's because they're using the serverless architecture. All right, and then the last thing is that it reduces complexity. So the perk of having it being fully managed is that you don't have to start worrying about scaling and all these things, and maybe start thinking about horizontal scaling and maybe involving it with Kubernetes. You don't have to worry about that stuff. And that actually significantly reduces the complexity. That really reduces that complexity. All right, so now let's talk about some of the cons of serverless. So one big con of serverless is cold starts. And that can actually significantly decrease the performance of your application. And let me explain to you exactly what cold starts are. So let's say you don't have a function. So you don't have a function, and now somebody came in and made an HTTP request, and this is of course a trigger for a function to create. But at the moment you don't have a function. So your cloud provider is going to have to create a function. And this creation actually takes quite a bit of time. Not an insane amount of time in the grand scheme of things, but if you want something to be extremely performant, well, this is going to decrease your performance because this is going to take some time to spin up, and then of course it has to execute the code and send back a response. And so when you actually don't have a function in the first place, the spin up of a function is known as a cold start, and that could take quite a bit longer than usual. So that is a con. But if your function is already spinned up and somebody else is making a request to it, then any subsequent requests are going to be very, very fast. And those are actually known as warm starts. So again, if you need high performance all the time, then cold starts is something that you have to worry about. Another thing is you're locked in. So you're really locked in with the vendor that you're using, whether it's AWS, Azure, or Google Cloud, because you're really relying on their serverless framework and what they are doing, and you can't really kind of manage it yourself. So that if that is a con to you, then maybe serverless is not something that you want to use. And the last thing is that serverless functions are not really suitable for long-term tasks. So these functions, they should not be executing for 30 minutes or an hour. They really should be executing some small piece of code like we have over here. Again, save something to the database, resize an image, run a quick cron job, send an email. They shouldn't be doing something insane like uploading a video or saving a video to your database. It should be some sort of small code executable. So if you intend to run some long executable code, maybe it's better to use some sort of server for that rather than a Lambda function. That should be something very, very quick. And I think actually Lambda functions time out after 15 minutes. And Lambda functions are basically functions that AWS uses, but there's many different functions out there. Like there's functions for Google Cloud Platform as well as Azure. All right, so that is pretty much the pros and cons. And now let's talk about some examples of serverless. So as I illustrated, vending machines are a great example of serverless. And actually Coke used to use the server model, and then they used the serverless model, and they saved almost half their money. So the cost actually went down by 50%, which is pretty insane. And the reason for this, I mean, this makes sense. The vending machine, you're not consistently using the vending machine. The vending machine is not consistently being used. So essentially, only a customer comes, and then they're going to make some sort of payment, and then you're going to have to process that payment right away, of course, and then send back whatever Coke that or whatever drink that they want. However, you don't want a running server to be running consistently because, again, this is very, very event driven. So you might have a period of time, maybe an hour or 2 hours, where nobody is using this vending machine. And so you don't want to have a consistent running server that is inquiring costs. Or even maybe it's nighttime and the store is closed down and nobody even has access to this vending machine. You really don't want to have a running server that is just continuously inquiring costs. So Coke actually realized this, and then they were like, hey, you know what, we're going to just use a serverless architecture. So we're going to only pay for when we are being used. So now what ends up happening is somebody comes in, they're going to make a payment, that's going to spin up a Lambda function, and then that Lambda function is going to process that payment and then send back a response to the software inside of the Coke or the vending machine. And then that's going to basically send back whatever drink that they want. But again, that really saved them a lot of money because now they're only paying for what they use. Okay, let's look at another example over here. So another example is CodePen. So if you're a developer, you probably know what CodePen is. But CodePen makes almost 200,000 requests an hour. And they have a DevOps team of 1. And that just goes to show how fully managed a serverless architecture can be. You really don't have to worry about the infrastructure at all. And the last example is Netflix, just to show you a company that really, a huge company that really adopts the serverless architecture. Netflix has been a huge proponent of serverless, and they use it throughout their software. And it just goes to show how powerful it can be and why it's such a necessary skill to learn. Alright, so that is serverless. I hope that got you excited, and I'll see you guys in the next sections. Now that we talked about what serverless is, let's actually create an environment where we can start spinning up some serverless functions. Now for this, we are going to be relying on AWS. Again, there's many cloud providers out there like Azure and Google Cloud Platform that have their own serverless functions, but I think by far the best ones exist in AWS. They are the absolute best ones, and they're used very, very commonly. Now in AWS, they're called Lambda functions. And this is essentially what we are going to be using. And you can see here, it says, run code without thinking about servers or clusters, only pay for what you use. So this is exactly what we want to use. Now what's great about these is that these serverless functions, they can run in multiple different languages. So let me zoom in here a little bit. You can see here that it can run in Node, it can run in Python, in Go or Java. So it doesn't really matter what you want to use. And I believe they also support Ruby, and you can see here it says more. So it's really supporting more and more types of languages. Now in this crash course, we're going to be using Node.js because I'm primarily a JavaScript developer, and so that is what we are going to be using. But the rules that we learn will apply to whatever language you ultimately want to use. And so we're going to be using AWS Lambda functions, and we're going to be using Node.js. Now, one thing that is very important to note is that you're going to need an AWS account to do this. And unfortunately, you can't create an AWS account without inserting your credit card information. Now, one thing is, with using this architecture, using AWS Lambda, you can see here that you get 1 million requests for free per month when you're using AWS free tier, which you will get for 1 year if using this. So you're going to acquire very little, if not no costs. I can pretty much guarantee you, I won't guarantee you, but I can pretty much guarantee that if you follow this, you're not going to acquire a lot of costs. You probably acquire nothing at all. So I just want you to be careful, but if you want to follow along, go ahead and create a AWS account, but you will have to put in your credentials. So please keep that in mind, and I'll show you how, once we're done this crash course, how to delete everything so that you don't acquire any more costs. But again, it should be very, very minimal, if not anything at all. Alright, so again, you're going to have to create an AWS account. I already have one. So I already have an AWS account, and it should look something like this. Now, I'm not going to show you the steps of creating an AWS account because, well, it's pretty easy. You just create one, put in your credentials, and then put in your credit card information. So I already have an AWS account. And now you can actually come here and you can actually search for Lambda. So let me quickly just search for Lambda, and you can see here that, hey, we can actually search for some Lambda functions. And you can see here that I actually have a bunch of different Lambda functions. And that's because I actually I worked on this course quite a long time ago. I was just preparing it. But let's actually just zoom in here a little bit. You can see that I created this to-do application. So you can see here that I have an update to do, and this is its own Lambda function. Similarly, over here, we have another to-do. This is an add to-do, and its own Lambda function is this way. And then similarly over here, we have a fetch to-do and a fetch to-dos. And so these are their own Lambda functions. And let me just click on maybe fetch to-do. And so you can see here that, hey, we have some sort of function right over here. Now, how are we triggering this? Well, we're triggering this function with HTTP requests. However, how is this HTTP request going to this Lambda function? And the thing is, it's not. What ends up happening is we have this other service called API Gateway. And through API Gateway, all of our HTTP requests are going to be made to API Gateway. And then API Gateway is going to relay those requests to whatever Lambda function we ultimately want to send it to. So again, this is how this works. So we send all of our requests to API Gateway, and then API Gateway then triggers the creation of a Lambda function. So that's ultimately what we're going to be doing. And so if we want to essentially configure Lambda functions that listen to HTTP requests, we also have to configure API Gateway. And we'll get to that a little bit later. But don't worry, this is just a quick example of how a Lambda function will get up and running. Now I'm going to actually go ahead. You might be in a different region. I'm going to go ahead and just go to US West 2. And if I go to that, you can see that I'm going to have absolutely no Lambda functions in here because the Lambda functions are actually region specific. So I'm going to pick a brand new region. And that's because, again, I want to have kind of a fresh start. So right now, there's absolutely no Lambda functions, and there's absolutely no API Gateway or any other configuration. So we're going to set this up from scratch. Now, there's few approaches of setting this up. We could set it up in the console. So this is basically the AWS website. We could set it up manually. We could just create a function if we want to. We can use some sort of blueprint or create it from scratch. And so you can see here the blueprints are, just some prototypical functions that have some code. So we can do this from the console if we want to, and then set up API Gateway ourselves, or we can do it through code. And what actually happens is if you do it through code and you have it communicate with AWS, it's just going to do all of these configurations for you. So you don't have to do it manually inside of the browser. And this is actually known as infrastructure as code. And this is a very, very popular approach of taking it. And that's why we're going to be using the serverless framework. So this serverless framework, essentially what it does is allows us to specify all of our functions and all of our configuration in code, and then it is going to create the functions for us. It is going to create an API gateway for us, all in AWS. So we don't have to worry about that manual configuration. And this again is a very popular approach. And there's other frameworks like Terraform that allows us to specify our whole infrastructure as code. So this is what we are going to be doing. Now, in order to allow the the serverless framework to actually communicate with our AWS account, we have to create an IAM account. And this is just an identity management service, which allows us to essentially manage who gets access to our AWS account. And so we need to allow this serverless framework and our local computer to have access to our AWS account. So essentially, now what we have to do is we have to create this IAM account. Now, the first thing we also have to do is create the AWS CLI. And the CLI is just a command line interface that interacts with the AWS client or our AWS account. And then we want to give that AWS CLI access to what we ultimately want to do. All right, so let's first deal with installing the CLI. So the CLI is very, very easy to install. So just go ahead and then install AWS CLI version 2. Go here and then install whatever version you need, whether it's Linux, Mac, or Windows. And I'm not going to go through it because it's a very easy install. And ultimately, just to double check that you installed it, you can go to your terminal and then you can do AWS, and then you should see a command that looks something like this. So if the command looks like this, then that's great. If the command looks like, hey, AWS not found, then okay, you didn't install it properly. Alright, so then the next step is we want to give the AWS CLI access to our AWS console. This is where we use the identity and access management. So to do this, what we're going to do is we're going to create a new user. I actually already created a user, so I'm not going to do this, but just to kind of go ahead, I'm just going to show you the steps of doing this. So I'm going to add a user, and you can call this whatever you want. I'm just going to call this serverless. And then we're going to give this programmatic access. So there's two different types of access you can give them. You can give them programmatic access or console access. Console access is, you give them a password and a username and a password, and they're able to log into the console. Programmatic access is essentially something like a CLI or SDK that just needs programmatic access. They're not a person that needs to log into the console. So we're going to give a programmatic access. And then what we're going to do is we're going to attach existing policies. Now, I know this is not best practice, and I know a lot of the AWS nerds are going to yell at me, but this is not an IAM course. So we're going to give our serverless user administrator access. But really, in a production application, you only want to give access for what this is ultimately using. So for instance, you're probably just going to want to give, if your user is only dealing with maybe S3, then you only want to give maybe S3 full access. And even then, you might want to fine tune it, maybe S3 outpost read-only access or something like that. But for the sake of this course, just to make things very, very simple, I'm just going to use administrator access, which means, hey, you have access to absolutely everything. All right, so go ahead and then click on next, and then next, and then create this user. So we're going to create this user, and then you should see an access key ID as well as the secret. So now what we have to do is we have to go to our AWS CLI and say AWS configure. So AWS configure. So go over here, AWS configure, and then it's going to ask you for the access key. So it's going to ask you for this access key. So just copy this access key and then put it in here. And then similarly, I'm going to show you guys this. So this is really dangerous that I'm showing you guys this, but I'm going to 100% delete this user after I upload this video. So you guys can try, but if I left this user on, then you guys would have pretty much administrative access of my AWS account, and that's really dangerous. But for now, I'm just gonna show you guys the next steps that I'm gonna do. So over here, you can see this, and then default region. I'm just gonna leave it as none, none, and then okay. So now our AWS CLI is actually configured with our app, or with our actual AWS console through this user. So this is pretty much all we need to do, and the thing is that you're never going to see these credentials again. So if you want to keep these credentials, highly suggest just download an SV or CSV. All right, cool. So we can go ahead and close this, and you can see that we have this admin user. I'm going to go ahead and just delete it right there, right in front of you, so I can 100% prove to you that, hey, this guy doesn't exist anymore. I'm just gonna consistently use the serverless admin. All right, so that is setting up the CLI, and I'm gonna have to, of course, change these credentials a little bit later, which is fine because it's not gonna work anymore. But now what we want to do is we want to set up serverless. Now, if we want to set up serverless and we want to go ahead and install it, then let's go over here to the documentation, and let's go to get started. And you can see that all we have to do is an npm install dash G for global, and then serverless. And this installs the serverless CLI for us. And this is going to spin up, again, a serverless project. Now, there's many different ways that you can do it. If you want, you can do it like this with Mac or with Windows. I mean, I suggest going this route, especially being that we're going to be creating a Node application. So I suggest going this route. But again, you can go whatever route that you decide to. But once you're done that, and I already installed this, so of course you're going to run this in your terminal. So once you're done that, now what you can do is you can do serverless, and in a little bit you can see basically, hey, what kind of application do you want to make? Do you want to make a AWS Node starter application, or do you want to make an AWS Node REST API application, or do you want to create a Python application? And you can see here that it's just different little things that we can create. And you can see here we have even others, and we can actually specify our own template. So now that we have all that set up, you can actually start creating our first serverless AWS application. Now that we did all of the setup, let's go ahead and create our serverless application. Now remember, we're going to be following an infrastructure as code approach. So we're going to be relying on this serverless framework to create the infrastructure for us. We're only going to provide it with the code. So let's actually go ahead and spin up a serverless project through this serverless CLI that we have already installed. Let me quickly just zoom in here. So to do this, and I think I already showed you this, just go to your terminal and then cd into whatever directory you want your serverless application to lie in. And then in here, just say serverless. So just say serverless, and then in a few moments, you can see a few templates that it will create this serverless application for. So we can have a Node application. It could be a starter, a REST API, a scheduled task, yada, 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 or a Python. And there's many other ones. There's like Java ones as well as Ruby. But we're going to rely with Node, and we're going to be working with the REST API, because that's essentially what we're going to be making. We're going to be doing a REST API. So we're going to go ahead and just say enter, and then it's going to say, hey, what do you want to call this project? I'm going to call this the default project, AWS Node REST project. Sure, that works fine with me. Now it's going to go ahead and it's downloading that template. Do you want to use the serverless dashboard? No, that's okay. And now what we can do is we can actually cd into that AWS Node REST API, and then we can open this up inside of our code editor. I'm going to be using Visual Studio Code, and for me to open that up, I have a neat extension called code dot. So once you cd into the directory you want to open, you can just do code dot, and it's going to open up VS Code. So you can see here, it opens up VS Code, and we get this kind of neat starter project. So we have a get ignore, we have some handlers, as well as this serverless.yaml file. So let's just quickly explore this right over here. So inside of the serverless.yaml file, this is essentially where we're going to provide all of the configuration that is going to spin up our AWS architecture. It is going to be dealt with over here. Our infrastructure is going to be dealt with over here. So you can see here that we have our providers, we have what we're calling our service. Our provider in this case is AWS, but we can change this if we want to Microsoft Azure or Google Cloud Platform. We have our runtime. So what are we using for our functions? We're using Node.js. And then over here we have some other things like Lambda hash, whatever. Another thing that I'm going to specify is the region. And for me specifically, I'm going to use a region that I haven't used before, and that is going to be US West 1. You can really pick whatever region that you want. I'm just going to use that region. So US, and this should be region, not regions, US West. I'm going to do 2, not 1, sorry. So I'm going to provide that in here. And then over here, we have this other block of code. And you can see here that this is the functions. So over here, we're specifying all of our functions. And you can see here that we have our functions. And then here we have hello. And this is what we are going to call our function. So this is like some sort of hello world function. And then we have the handler, and that's the function itself. So that is the function itself. And you can see that it's linked to, well, handler.hello. So you can see here that we have our function right over here. And essentially all that this function is doing is just returning a status code of 200 and then returning something in its body as well. So ultimately it's just going to execute this piece of code. Obviously we're probably ultimately in our function is going to have some real logic going on. I'm just going to not return something right away, but this is just an example. And now what triggers this function? So what triggers this? Well, what triggers this function is events. Certain events can trigger this function, and we can have multiple different events. But over here, we're saying that, hey, the event that is really going to trigger this function is an HTTP event. And this is path, well, this path, so path nothing, and the method is get. So this is a get request. So that is pretty much it, and this is a valid serverless application. Now this isn't in the cloud yet, so what we have to do to actually get it into the cloud is, and get it into our serverless app, is to do serverless deploy -v. And essentially what this is ultimately going to do is create the infrastructure for us inside of our AWS application. So quickly, before everything deploys, let's just go to Lambda. And you can see here that initially there should be nothing in Lambda, and also there's nothing in API Gateway. There should be nothing in API Gateway as well. Well, actually, I guess there is something, but that's from previous ago. So that was a very long time ago, actually. Actually, not really a long time ago. That was maybe a few days ago. But it's not for today. So you can see here that it's still going to be creating it. So let's just wait. And it's creating not just, it's creating multiple different resources. So CloudFormation, you can see here, we got S3. So there's a lot of different things that we don't even have to worry about when dealing with infrastructure as code. So just wait a little bit. This might take some time. This initial deploy will take some time because we're spinning up a lot of different servers. You can see here that we created a Lambda function called hello Lambda function. You can see that it has been completed. We have created API Gateway. And now I think if we go back over here, maybe if I did a refresh, you can see here that it actually spinned up this. So you can see the API Gateway at work. So essentially what's happening here, and let me just quickly zoom in. So when you make a request right over here to /get, then what happens is that it's going to execute some sort of Lambda function. So it's going to execute this Lambda function, the hello Lambda function, and then that's going to go ahead and send back a response to the client. So the client, they're going to be making a request to this API Gateway, which is going to delegate it to this Lambda function, and then that's going to send back a response to the client. Now let's actually go ahead and you can see here that this is the endpoint that has created. So this is just an HTTPS endpoint. So to test this out, let's just go to our browser, and then let's just execute this GET request. And you can see that we get back our data. So you can see here that we have Go serverless, and then we have a bunch of other code. And this is basically the 200 response that we get back. So that is pretty much it, and you can see how easy it is doing it through infrastructure as code. In the next sections, we're actually going to be coding out our real application. Before we start creating our Lambda functions, let's just do a little bit of cleanup inside of our directories. Most notably, what I want to do is I want to create a folder where I can put my functions in. So I want to have a file for each particular function, and I want to store it inside of a folder. Right now, basically all our functions lie in this handler.js file, and I really don't like that. So let's go about fixing that right now. So the first thing that I want to do is I want to create a source directory. So I'm going to have a source directory, and in here all of our functions are going to live. So let's actually go ahead and let's just copy this in right over here, and let's just move it in there and just paste it in there. So now what we have to do is just a few little things. So now what we have to do is let's just go ahead and let's change this to an arrow function. So let's do const hello is equal to this particular function over here. And then in the very bottom, all we're going to do is a module.export. We're going to export an object where the handler is equal to that particular function. So now what we can do is we can go ahead and say that the handler is the hello function, and we can actually change this file to be now a little bit more descriptive. So now this is the hello function. All right, so of course now what we have to do is inside of this block of code, we have to change where our handler is actually living, because right now it's living inside of the source directory inside of this hello.js file. So this is very, very easy and simple. Now all we have to do is specify that we want you to go to the source directory, and then inside of the hello.js file, we want you to take out this handler, which corresponds to the hello function. So we're just going to say hello.handler. And that should pretty much be it, and that should work perfectly fine. And this is going to be the way that we organize our structure. Now, one thing that you can do is inside of this source directory, you could create a handler directory and put all of the functions in there. And that way you can actually have other things as well. And that's actually probably the best approach. But since we're only going to have functions inside of our source directory, I'm just going to stick them in there. But again, with larger applications, it's actually probably better to organize your functions in a handler directory inside of the source directory. And then inside of the source directory, you can have other things like tests or maybe a lib or utilities folder. Okay, but the way that you would do it is very, very similar, exactly the way that I did it right now. So let's go ahead and save this, and let's just go ahead and SLS deploy this again. So let's just do SLS deploy -v. And this essentially, if everything works out, should deploy, and we should ultimately get the same results. So hopefully this doesn't take too long. It seems like it is kind of taking a long time, but it should speed up. I do not want to pause the video, so hopefully this speeds up a little bit. So it's recreating AWS CloudFormation, which we'll talk about a little bit later. And it seems like everything is fine. This one was a lot faster actually, because we already deployed a lot of our infrastructure already. So now what we can do is you can see that this is our endpoint right over here. And we should also have a /hello, or actually no, we don't. The path is just the regular directory. So now what we can do is we can basically just copy this endpoint, and we can either use our browser or we can use Postman. I'm going to use Postman, and what I'm going to do actually is I'm going to go ahead and create a serverless folder. So I'm going to rename this to serverless, and I'm just going to create a new request. And so let's call this request, well, this is going to be the hello request, which we'll change a little bit later. We're going to, of course, remove that. Hello. All right. And then this is a get request, and we're just going to go ahead and make this request. And it works perfectly fine. And so you can see here that we get our data back. So this is how we are going to be organizing our structure. Now in the next section is let's actually go ahead and start creating our functions, our to-do functions. So let's start talking about the functions that we are going to be creating. So these are the three functions that we are going to be creating. We're going to be creating the add to do function that is responsible for adding a to do inside of our database. And then we have a fetch to do. So this only fetches one specific to do based on the to do's ID. This one over here fetches all of the to-dos, and this one over here updates the to-dos. And specifically what this does is it just updates the to-do from completed to incomplete or vice versa inside of our database. Now the thing is we actually need a database for this to happen, because again, remember how our functions work. We can't really store data in here, because if we do decide to store data in here, eventually this is going to go away completely. And plus, again, if we decide to store data in here, another function that is responsible for fetching data has no communication to this function. So we need to store our data inside of a database. Now there's a very popular NoSQL database inside of AWS called DynamoDB. And so if you go to your AWS console and then you search up DynamoDB, you should be able to see it right here. And you should be able to see something that looks like this. I'm not in the correct region. Let me go to the correct region where I know I don't have an instance. And you should be able to see something that looks like this, where you can create your own table. Now you could do this through the console, but I highly suggest doing it through an infrastructure as code approach. And we can do that through the serverless framework. So inside of this serverless.yaml, we can actually define outside resources that we ultimately want to provision. And this doesn't have to be just DynamoDB. This could be S3, or this could be maybe an RDS instance or something else. We can all define that in here in this YAML file. And we define all the outside resources, as you can imagine, in the resources column. So this is just basic YAML. And maybe I'll have a crash course on YAML a little bit later. But over here, we're going to have resources. And then we're going to have basically colon. And then anything basically under here, we're going to have a bunch of indentation symbolizing that this is going to be scoped to this resource over here. This is where we're going to define all of our resources. Now, anything below here for AWS is going to be CloudFormation. And don't worry all too much about CloudFormation. Maybe I'll cover it in a different crash course. But we're going to be using CloudFormation to define the resources that we are going to be using inside of our AWS application. So the first thing we have to do is, with CloudFormation, the capitalization is very important. We're going to have to also then define resources again. And what we want to ultimately define is some sort of resource. Now this resource, we're going to have to give it a name. And I'm going to call this resource the to-do table. So the to-do table. Now this resource right over here, well, we're going to have to now assign it to a specific type, whether it's an S3 or it's a DynamoDB or it's, again, RDS or whatever. We're going to have to assign this particular resource to a type. So I'm going to say that, hey, this type is AWS : DynamoDB, and then : from DynamoDB, we want a table. So that is the very, very first thing. And then we're going to have to define some properties for that resource. So the first property, and this property is going to be, the properties are going to be very, very different depending on the type. So for DynamoDB specifically, we have a property that we need to assign called table name. Let's just call this to-do table, similar to the name of our resource. This does not have to be a one-to-one match. This is the name of the resource. This is the name of the table name. All right, and then we also want to define the billing mode. And we're going to say that the billing mode is pay per request. So that's how we want to be billed. Don't worry, you shouldn't be able to inquire that much costs. And later on, we'll talk about how we can just completely get rid of everything. All right, and now one thing that we have to do is for each record, we have to define an ID, a primary key. So something that will uniquely identify each record. So what we have to do is define a certain attribute. We have to tell our table that this attribute will always be our primary key and it will always exist. So to do that, we first have to define the attribute. So we can do that through the attribute definition. So attribute definitions. And then over here, this is going to be an array entry. So you do that with YAML through this minus sign. And then we're going to say, specify what the attribute name is. And this is going to be ID. And then we also have to say for that specific attribute, what the attribute type is. And for this, that is going to be a string. So that just defines that, hey, we're going to have an attribute of ID and string. Now what we have to do is define that, hey, this is going to be a primary key. So we do that through key schema. And then what we're going to say is we're going to say, okay, well, which attribute is the key schema? Well, that is going to be the attribute name. And the attribute name is the ID. So here we're just defining the attribute. And here we're telling it that, hey, this attribute is going to be a key. And then we're also going to have to define that the key type is hash. And this basically ensures that, hey, this is going to be our ID. All right, so that is pretty much all we have to do. Let me just quickly double check. Attributes is a very easy word to misspell, as well as definitions. So everything here seems fine. I highly encourage that you double check as well. So now what we can do is we can go ahead and save this. And we can go ahead and now just do an SLS deploy -v. So if we do this again, what's going to happen is it's going to create that DynamoDB table for us. And actually, in the meanwhile, we're going to have to do a little bit of installation. So we're going to actually have to install some new packages. So let me go ahead and open up a new terminal. And now what we want to do is we want to install a few packages. So we're going to do an npm install, or actually before we do that, let's do an npm init-y to generate a package.json. This is all assuming that we have npm installed or node installed on our local machine. And then what we can do is we can do npm install, and what I want to install is I want to install UUID, and I also want to install the AWS SDK. And the AWS SDK is going to allow us to have a lot of different functions that we can use, as well as DynamoDB, to perform some sort of action. So let's go ahead and let's just make these installations. And now let's go back over here, see if we got any errors. It doesn't seem like it. Everything seems fine. But now you can see that we actually created a table. So if we go back here and we refresh, we should see a table. So we see some new kind of UI, and that's because we actually created our table successfully through an infrastructure as code approach. All right, cool. So that's pretty much it. So I'll see you guys in the next section where we're actually going to work on, for real this time, our application. Okay, finally, let's go ahead and let's just create our functions. Ultimately, these functions are just going to be regular JavaScript. So if you're familiar with REST APIs, this should be relatively simple, but those functions and those block of code are going to be executed by the functions that we eventually invoke rather than our server that will listen to a particular route. So that's really the only difference. So let's create the add to do function first. So let's go ahead over here to our hello handler. And the first thing I'm going to do is I'm just going to go ahead and just rename this to add to do. So we're going to rename that to add to do. So the first thing in here is we're going to go ahead and let's just rename this also to add to do. And you can see that it returns something that looks a little like this. So we have the status code, which is 200. And then we also have our body that we JSON.stringify, of course. So let's go ahead and let's get our data from the event, because once the user is making a request, they're going to send the information inside of the request body. And that's going to be living inside of the event.body. Now for this case, we're going to create a to-do that has 3 attributes: the ID, the to-do itself, when it was created, and then the completed status. So that's really all we're going to do. Now, for the user, they really just have to provide the to-do. So whatever they want to do. We're going to generate the ID. We're going to generate the created at, which is going to be at the moment that the object was created at. And then also the completed, initially we're going to set that to false. So from the rec.body, what we want is const. We're going to go ahead here from the event body. We want to get back just the to-do itself. Now, one thing that you note is this is going to be stringified. So to actually get access to it like a regular object, we have to json.parse it. Now this can get annoying, so what I'm going to do later on is apply some sort of middleware that will automatically parse the event body, so we don't have to do this manually, but for now we'll just do that. Alright, and now let's go ahead and let's create the created at. So we're going to create the created at, and that's going to be just new date, and this just creates the date at the current moment of when this variable was created. And then what we're going to do is we're going to want to also create the ID, and that's why we installed that UUID package. So now over here, what we can do is we can do const, and we can require something from that UUID package. And UUID has different methods that we can use: V1, V3, V4. These basically create different types of UUIDs. V4 is by far the most common. So what I'll just say is V4, and we can go ahead and invoke it. And that's just going to create a UUID for us. All right, so that pretty much sums that up. So now what we want to do is we want to save that into our DynamoDB database. So that is why we installed the SDK. So now what we can do is we can do const AWS, and we can require the AWS SDK. And then from the AWS SDK, we can get access to DynamoDB. So we can do const DynamoDB is equal to AWS DynamoDB.document client. And now what we can do is with DynamoDB, let's actually just cut this and put it right at the top because it just seems a little bit cleaner. Now with DynamoDB, what we can simply do very, very easily is DynamoDB, so DynamoDB.put, so DynamoDB.put. And essentially what we can do is we can basically say that, hey, we want to put inside of the table name, and this table name is the to-do table, we want to put a item. So we want to put an item. Now, what is that item? Well, it's this whole object. So we can basically define the whole object in here. And actually what I think might be better is to just say const new to-do, and that's going to be equal to an object. And we're going to have the ID in here. We're also going to have the to-do itself. We're also going to have the created at, and we're also going to have the completed status, which we will initially set to false. So now what we can do is we can say that this new item is the new to-do. Now this is going to be asynchronous, so we can await this if we want to. So we can go ahead and await it. And then over here, what we can basically do is, let's get rid of all of this. Let's actually get rid of all of this right here. And then essentially all we're going to do is we're inside of our body, we're going to send back the new to-do that we have created. So we're going to save this. Now this is not going to work. And now one reason why it's not going to work is because we have to do add to do. And then also we have to change it over here to add to do. And might as well also change the function to add to do. And also, let's say we also want to do some sort of debugging. So let's just say console.log. You know, this is an ID. This is just how I can show you how we can actually view logs. This is an ID, Now, currently this is not going to work. And the reason why this is not going to work is because that Lambda function that we invoke actually doesn't have permissions to use the AWS DynamoDB and actually put data into it. So we actually have to give our functions permissions to do that. So how do we go about doing that? Well, we can do that very, very easily inside of the serverless configuration. So inside of provider, what we can basically say is IAM role statements, and we can say that all of our functions have access. We're going to basically have an allow access, and then we're going to say that, hey, they are able to perform all of the DynamoDB actions. So I'm going to say every single thing. Now, this is probably not the best practice for IAM. You probably want to say that, hey, our functions maybe only have put access or get access. But for simplicity, I'm just going to say absolutely everything. And then what we have to say is, okay, well, they have access to put, literally to do anything with DynamoDB, but we also have to specify exactly which table they have access for. So to do that, what we have to do is we have to say resources, and then we have to have a unique identifier for that specific resource. Now in DynamoDB, that unique identifier, if you go to tables, you can see the table itself. So you can click on the table, and that unique identifier is the ARN. So now what we can do is we can just paste the ARN in there. And now basically what we're saying is all of our Lambda functions can do whatever action to the DynamoDB to-do table. So that is pretty much what we are doing right now. Let's do an SLS deploy, and let's try to see that in action. So let's do SLS deploy -v. So let's hope that this works. Seems like everything is fine. We did add quite a bit, so I'm hoping we didn't really break anything, but it doesn't seem like we did. So let's just wait. So actually what we should be able to see is if we go to our Lambda functions, we should be able to see maybe a little bit later on a new Lambda function. It's still being created. But we should be able to see a new Lambda function that is not hello. We actually deprecated this hello, so we could, if you want, completely get rid of it. But I'll keep it for now. So we can see. One thing, the reason why this is so slow is because we're redeploying our whole infrastructure. Now, if we just made a change to our function itself, we don't have to actually go through this whole process. There's actually a shortcut that we can use to basically just deploy that function, and that's a lot faster, of course, than dealing with this whole process, as you guys can see. But you can see here that actually, which is really cool, it actually deleted the hello function because that doesn't exist anymore. So if I were to refresh this, I actually shouldn't be able to see this anymore. And you can see it actually got converted to the add to do function. All right, so that is cool. One issue is I just realized that this should be a post request, which is unfortunate. So we should actually be changing this to post. So let's actually go ahead and let's redeploy that. But as this redeploys, let's actually create some of the other functions. So let's go ahead over here. And let's now create the fetch to-dos where we fetch every single to-do. So let's go here and let's say fetch to-dos. So where we fetch every single to-do. This one should be a relatively easy function. Let's actually just copy this format. And we're probably not going to use the UUID. We're going to call this fetch to-dos. Now we are going to need the DynamoDB, and we're not going to need any of this stuff. We're not going to need any of this stuff. DynamoDB we are going to use, but a little bit differently. Other than that, I think that should be fine. Over here, let's just change this to fetch to-dos. And then, okay, it seems like this has deployed. So what I'll do is I'll show you guys now that this post request is working perfectly fine. And another thing that I actually noticed is that, okay, this is a post request, but maybe we want to change the path as well. And we can change the path if we want to by appending a slash over here. Now I'm completely fine with having just this root path because this works out perfectly fine with me. So now what we can do is we can just create a new request, and we can go ahead and make a post request, and inside of the body, remember we have to provide the to-do inside of the body. This is a little bit too zoomed in. So we have to provide the to-do, we have to go raw, JSON, we have to say to-do, and let's say our to-do is make a YouTube video. So if I were to make this request, it should give us an internal server error. And this is actually good that it gave us an internal server error, because now what it'll allow us to do to actually debug what's going on. So it might be really hard to debug things if with serverless, because we're not really ever doing anything locally. Now in a typical application we could run it locally, but it's actually better to have maybe a dev, staging, and then production environment. Here we're just really deploying to, I guess, production, even though this isn't really a production application, but we could also specify a dev, staging, or production environment. But now let's actually try to investigate exactly what is going on here. Now typically when you're running things locally, you can see the logs right away, and you can see the errors that happened right away. Now this is kind of problematic with this approach because everything is inside of AWS. Now to see the logs, what we can do is we can actually use another service called CloudWatch. So we can go to CloudWatch, and this might not be the prettiest way of doing it, but this is a pretty good way of doing it. Then you go to log groups, and then you can see here that we have our functions. And essentially what happened is when we created our function, this was automatically configured for us. So now what we can do is we can click on this, and we can see that I just made this request today at this time, which is 8 p.m. And what we can do is I can click on this, and I can see all of the logs. So now I can click on this log, and then click on this log, and I see here, okay, we have some sort of error, and it says type error. So self.configure is not a function. So I'm not sure actually why that's happening. So let's open up some other logs over here. But it says here again, yeah, self.configure is not a function, and that is the error that is happening. So let me see if I can quickly diagnose it right now. If not, I'll pause the video and figure out exactly why that's happening, because we don't really have a self.configure here. I'll just pause the video and I'll come back with a solution. So I figured out what the error was. It was a very simple error. Over here in the DynamoDB, I should have put the new keyword to instantiate DynamoDB, because we have to instantiate this particular object. So just add new in here, and what you can do now actually is instead of doing SLS deploy -v, because we only changed this particular function, we could do something like SLS deploy -f and specify the new function that we want to redeploy. And this essentially is a lot better because it is a lot faster. So this is really, really cool. And now if you go to Postman and you make that same request, you should be seeing this ID right over here. And now what we can do actually is we can go to CloudWatch, and notice this console.log that I put in here. This is just in case we need to console.log to debug things. So now what we can do is we can see here that we have another log group, and we can basically open these up, and you can see here that, hey, this is the UUID. So if we ever need to debug and console.log things, we can just go to CloudWatch and do that. So now let's go to DynamoDB, where we actually inserted our record. So let's go to tables, let's go to the to-do table, and then let's go to items. And you can see that we don't have any items for some reason. Let's go over here. I would have thought we added an item in there. I guess we didn't. That's interesting. That's another thing that we are probably gonna have to debug. Am I in the right? I am in the right. What I'll do is let's actually create the fetch to do, and then let's see if that results in the items. Because sometimes this is actually slow for it to appear. But you know, I would have expected it, but I guess it didn't happen. But let's create this, and then if this returns back an empty array, then we know that we have something wrong over here. So the first thing that we're going to do is we're going to have the new in there because that's definitely important. And let's actually say that, hey, let to-dos be, we're just going to declare the to-dos in here. And then what we're going to do is we're going to say const results is equal to await, and then we're going to say DynamoDB, and we're going to do e.scan to basically get all the records inside of the particular table that we're specifying. So we're going to say here table name, and then we're going to say, well, this is going to be the to-do table, and ultimately this is going to return a promise. So this is going to return a promise. Now this could fail, so what we are going to do is just put this in a try-catch block. So we're going to put it in a try-catch block. If it is successful, then what we're going to say is we're going to say to-dos is equal to results dot items, which is basically every single item. If it's wrong, then what we'll do is we'll just console.log the error so we can view the error in CloudWatch. Now what we ultimately also would want to do is return some sort of error to the server, but I'll leave that up to you guys later. So now what we can do in here is just say that, hey, we want to send back the to-dos. So that is our function, very, very, very simple. So now inside of the serverless, what we have to do is create a new function. So let's actually go ahead and let's copy this down. And let's paste it in there. And we're going to call this function fetch to-dos. We're going to say that this is in the fetch to-dos.handler. And let's actually, just spice it up, and let's just say /to-dos. And over here, this is going to be a GET request. So let's go ahead, and this time we have to do SLS deploy -v and deploy our whole infrastructure. And the reason for this is because we have manipulated the serverless.yaml file. So let's go ahead and do that. Hopefully this doesn't take too long. I keep saying that, but it always takes the same amount of time. So while that's happening, I'm so bothered that the data wasn't actually saved. Let me quickly do a refresh. I'm sure the data wasn't saved. Yeah, it's not saved. I'm not really sure why, but we'll debug it. Don't worry, we will debug it for sure. So let's actually see as this is deploying. Good time to kind of debug. So we have over here, we're putting this item in there. That's interesting because it seems like this should theoretically work. And we'll be able to test it out exactly why it doesn't work when we actually have this get function, which at this point we do. I think the reason why it's not working is we actually have to send back a promise, even though I think this is part of the response. We'll double check. Now let's go ahead and let's actually redeploy this function specifically. And so this should be a very quick redeploy because we're only redeploying the function, so it shouldn't take as long. And then what I'm going to do is let's go ahead and let's get this right over here, this URL, and let's create a new request. And this is a GET request, and we're just going to go ahead and make this request. So you can see that this actually returns back an empty array, which is great because that's exactly what our database is holding right now. Now we know that this route works, but we know that this route doesn't work. So hopefully maybe that fixed it, the promise fixed it. So now let's go ahead and let's make this request again, and it actually was that. So you can see here that it works perfectly fine. And now if I were to refresh, I should be able to see the record in there. And I do, which is cool. You can see here my ID, false, and then created at. That seems to be an empty object, which is kind of strange. But you know what? Whatever. I'm just going to leave it like that. I don't really care. And then we have our make a YouTube video. And the reason why it's probably a object is because we have new date over here. I don't know if we have to do like some to ISO string. Maybe that will fix it up. And maybe we'll go ahead and just, well, we'll redeploy it with the other one. So now let's actually create another one. And this is going to be the fetch to do function. So fetch to do.js. It's going to be very, very similar to the fetch to do. So I'm just going to go ahead and just copy this. Except here we're only going to be fetching one specific to do based on the ID that was provided in the parameter. And let me just show you exactly what I mean by that. So over here, we have here getting all the to-dos, but this route is going to be a little bit different. It's going to be slash to-do and then slash the ID of that to-do. And that should only get us one to-do instead of every single to-do. So over here, it gives us an array of to-dos. This route should give us just that one object. So let's go about doing that right now. Oops. Let's just move that back to the to-dos. Okay. So now what we want to do is we want to create this. And I think it might be worthwhile to just create the function over here in the handler. So let's go over here. We're going to say that this is the fetch to do function, and this is going to go over here to the fetch to do, and this over here is going to be to do and then a dynamic ID. And to define that in serverless, we do these curly braces and then ID. Okay, so that is how we define it here. And then now what we can basically do is we'll use DynamoDB to extract everything. So that dynamic ID is going to be living inside of the event.path params. So what we can basically do is we can say, okay, the ID is equal to event.path param. So we can basically destructure that ID out from the event.path params. And then what we can basically do is we can have another try catch block, but instead this time it's going to be dynamodb.get. So this is going to be a get request because we're getting basically for a specific key. So we're going to say that the key is the ID. So we only want to get to one item where this is the key. So we can even space this out just to make it look a little bit better. And now what we can do is we can say that the result is going to be results, or maybe this is more promptly named result, and then this is going to be result.item because we're only getting one item back. And over here we can probably change this also to do. Okay, and we can change that back to over here to do, and over here we can change this to fetch to do, and over here similarly fetch to do. So I think that's it for that. I don't think anything is wrong with that. So let's go ahead and save it and let's redeploy our whole infrastructure. So sls.v, and by the way, if you're confused by SLS, this is exactly the same as serverless. I probably should have mentioned that, but it's just a shortcut because, you know, typing serverless can get pretty annoying. Now in the meanwhile, let's create our absolute last function, and our last function is the update to do. So let's go ahead and let's create a new file. We're going to call this update to do.js. And we're going to go ahead and just copy the add to do because it's going to be relatively similar. Let's just change this to update to do. And over here to update to do, and then everything else we're probably going to be getting rid of. Let's actually create the serverless for this first. So let's go over here, And this is going to be also a little bit interesting, or it's going to be kind of a combination of this post request as well as this get request, because we want to update a specific to-do based on the ID. So we're going to have this exact same path with the ID, but we're also going to be injecting essentially what we want to update inside of the post request. But now that that's done, let's actually just test out the get. So to test out the get, what we can do is we can basically get this ID, and we can just do /ID, and it should work. And see, it doesn't give us an array of objects, it gives us only that specific object. So it works perfectly fine. So the last thing that we have to do is just create that update. So so the handler is going to be updates to do, and then over here updates to do, and I think that is pretty much it. We can also change the request to a put request or a patch request, whatever ultimately you think is best. And now let's actually go ahead and let's create this to do. So the new to do we can probably get rid of. The console.log was only for our sake. Now in terms of the event.body, we want to get the completed status. So we want to get the completed status from our client, and so whether this is true or false. So that's really the only thing that we want to update. But we also want to get the ID, and we get the ID from the param. So remember, inside of the fetch to do, fetch a specific to do, this is how we get our ID, and we can get it in this very similar way in this serverless function. All right, so that is pretty much it. And now the last thing is we have to go ahead and update it. So instead of put, we're going to say update. We're going to say that we're going to update this particular table, and we're going to provide a key, and this is going to identify exactly what object we want to update. So over here we have the key, and then over here we're going to have another field called update expression. And then over here, this might be a little bit funny syntax, but it might make sense at the end of the day. We're going to say that, hey, we want to update completed. We're going to set completed to completed, completed. And essentially what we have to do is we actually have to inject this completed value in here. So now we can say we want to set the attribute completed to this completed value that we basically injected from here. To actually inject it, what we will have to say is expression attribute values, and we can basically say that, hey, the completed is equal to the completed object right over here. So that's basically, this is basically saying set completed equal to this. We're just mapping this to that. So that is pretty much all we have to do. And then lastly, we have to define what we ultimately want to return, because we can update a bunch of things. We're going to say that, hey, we want to update, or we want to return all objects that have been modified. So all new objects. All right. So ultimately we want to return the promise. So that is pretty good. And then for the stringify, well, we updated it. So what I'm going to say is just provide a message telling us, hey, this to do updated. We could return the actual to do, but I'm just I don't yeah, it's fine. I don't want to do that. All right, cool. So that is pretty much it. So now let's go ahead and let us do an SLS deploy. This might take some time. Now, in the meanwhile, let me actually tell you what we're going to be doing next. You can see here that this JSON.parse is pretty annoying, and this is same over here. So what we can do is we can actually add middleware. So if you don't know what middleware is, it's basically something that is invoked before the actual execution of our function. So what it might do is it might do some sort of processing. And middleware are actually very important for authentication. So they're often sometimes run for determining if the user is logged in and they have authorization to this particular handler. So what we can do is we can actually apply middleware that parses the JSON for us beforehand, so we don't have to do it manually. And so that is what we are going to be doing next after we test out this function. So let's go ahead, and it seems like everything is fine. So what we can do now is we have a put request. So we have this put request. So let's go ahead and let's actually make this call. Let's add another request. And we're gonna make this put request. And what we're gonna do is inside of the body, we're gonna say raw and then JSON. And we're gonna say that the completed status is true. And we're gonna say that the completed status is true for this object right over here. So let's get rid of that, let's paste that in there. And now we're gonna say that this is a put request right over here. And so now we can go ahead and send this off. It says updated to do. And we can actually test this by making this request again. And it's getting rid of that. Let's make this request. Oh, yeah, of course. We have to make this request again with that particular ID. That's why we're missing that token. So we can make this request. And now you can see that it was updated to true. If I were to change this to false, now what we can do is make that exact same request, and you can see that that works perfectly fine. So that right there is Lambda functions. I hope that makes a lot of sense. Now let's just apply middleware, and then we'll be done with this project. Okay, so the last thing that we want to do is apply middleware. And for serverless framework, there's actually a really great package that we can install that will allow us to use middleware very, very easily. And that's called MIDI. So what we can do is we can do a npm install, and then this is going to be @MIDI and then /core. Now within the MIDI package, there's many other packages that we can install that are middlewares that we can use. For instance, we can use @MIDI, and then this middleware is HTTP JSON body parser. And you can imagine what this middleware is going to be doing. So let's go ahead and let's install this. And if you don't know what it's doing, well, what it's going to do is actually parse our JSON body. Now, sorry, apologies, it's MIDI, not with without the L. So let's get rid of that. I always make that mistake. So let's go ahead and now let's actually use that MIDI middleware. So inside of the add to do, what we're gonna do is we are going to do const MIDI, and then we're gonna require in MIDI from @MIDI core, and then we're also going to get const HTTP JSON body parser. So we can do HTTP JSON body parser, and then we can do require, and we can do @MIDI JSON body parser. So simply to use the middleware, what we will do is basically wrap this handler in the MIDI method. So we can say MIDI, and then we can start appending whatever middleware that we want to use. So we can say that, hey, we want to use the HTTP body parser. So now what we can basically do is let's get rid of this console.log. We can basically get rid of this JSON.parse, and that's because we already parsed it inside of the middleware. So if I were to do a SLS deploy-v, and I'm doing a SLS deploy-v because I guess we changed the function, but we also changed the package.json and the node modules. I really don't know if that matters or not, but it could matter. So I'm just going to deploy the whole thing just in case. Now you can do the exact same thing with the update as well. So we can basically say, let's actually just copy this. And then in here we can say MIDI, and then over here we can get rid of the parse. And then over here we can just simply wrap this in MIDI, and we can say .use, and we can say HTTP JSON body parser. So let's actually go ahead and let's add another to do, and this time we're not parsing the body, so we should keep that in mind. And let's say walk the fish. So let's go ahead, and it works perfectly fine, and that's because of the middleware. And we can actually append any of our custom middlewares as well if we want to. So the middleware, as you can see, this is the interface of the middleware, but you can have a custom function, and you can basically have the .use in there if you want. So you can really do whatever it is that you want. So that pretty much sums it up. I hope you enjoyed the crash course and learned a lot about serverless.